If you are trying to prepare for competitive exams like JEE or NEET, units and measurements is the first chapter that will contribute to the terms. So today I would like to go through the chapter and discuss the important problems or the concepts in the descending order. I, that is the highest priority at first, and moving to the lesser important stuff. According to me, the most important part of this chapter is dimensionality formulae and dimensional analysis. So the first thing to note is what it said here, the base quantities. These provide the 7 dimensions of the physical world. So these 7 dimensions are the length, mass, time, electric current, temperature, luminous intensity, and amount of substance. Each of them is represented, as you can see, in the square brackets. From this, we can represent every quantity in terms of this. So the next point to note is that every physical quantity, which could be force, work, energy, momentum, molality, strain, stress, spring constant, tension, specific heat, thermal coefficient, everything can be represented using just these 7 dimensions. So it would be nice if you could try to do some of these and represent it in terms of the dimensions. Now comes the next step, which is most probably asked in the problems in competitive exams, is dimensional analysis and dimensional equations. Among the application of dimensional analysis, the most important one is the principle of homogeneity of dimensions. According to this principle, every term in an equation should have the exact same dimensions. It's a very basic principle. So if we are looking at an equation, every term in each of the LHS and the RHS should have the same exact dimensions. And here they have given an example of the linear kinetic motion. Every term is of the same dimension of length. Then comes the other most important point. If the equation fails this consistency test, then the equation is definitely wrong. If an equation has to be true, it has to satisfy the homogeneity condition. That is, every term should have the same dimensions. But very important point, if the dimensions remain the same, it does not guarantee that the equation is right. This is because there could be many other numerical factors which cannot be incorporated into the dimensions. So there could be mistakes in that case. So we will always have to verify it with real life situations. So if we find that dimensionally it is wrong, then the equation is definitely wrong. But if it is dimensionally right, it is not a guarantee that the original equation is right. Then this is one of the most common problems from this chapter, which is to find the dependence of an equation on certain quantities. So here in this problem, we are considering the dependence of the time period of the pendulum. But to start with, we have to assume some relation, that we assume that the time period is dependent on the length, the gravitational force, and the mass of the pendulum. From these, we can deduce the relations and find the dependence of individual factors. It is shown in this example here. It is a very important problem and you should definitely go through it very seriously. But it is just a simple application of the homogeneity principle that we learned already. Another point to note from this is that it does not give the proportionality constant. So we can see that dimensionality analysis is very useful to reduce relationships, but it cannot be used to find the exact equations. Now the next most important part of this chapter is error analysis. I have already done a video, a very detailed one on error analysis. So if any of you want to go check it out, you can find it on my channel. The other important concept introduced in this chapter is that of the significant figures. It shows the precision and the accuracy of a certain measurement. Basic rules for that is given here. I think you should be able to go through this without me doing much of things, but I have to stress on one point here, that the third point, to remove such ambiguities in determining the number of significant figures, the best way is to report every measurement in scientific notation. They have shown an example here in which it seems that the change of units is changing the number of significant digits, which is obviously not true. So, in order to avoid all such confusions, it is always better to report the measurements in scientific notations. Scientific notations are those of this form, and they have given the same example here in the scientific notations, and we can here see that it is consistently 4 significant digits. And now the change in significant digits while we are doing arithmetic operations. So there are two main important points. First, in the multiplication and division, we should count the significant digits of each measurement, and in the final answer, the number of significant digits should be the same as that the original number which has the least significant numbers. So in this example, the density is the mass has 4 significant digits, that is 4.237, and the volume has only 3 significant digits, so 2.51. So the final answer should have only 3 significant digits. So we will round off the fourth one. So the final answer should be 1.69. In case of addition and subtraction, we don't have to look at the number of significant digits, but we look at the number of points after the decimal place. So in the final answer, we should have as many decimal points as the original number with the least. So in this example, we are taking the sum of 3 numbers, and among those the number with the least number of decimal digits is 227.2. So in the final answer, we should have only one decimal place. Now for the final concept you should remember is that of the angle and the parallax technique. So the angle in radians is given by the ratio of the arc length divided by the radius. It is also very easy to remember. We know that the circle is 360 degrees, and we know that 360 degree is equal to 2 pi radians. So if we look at the total arc length of the circle, which is equal to the circumference, which is 2 pi r, divided by its radius r, gives the answer 2 pi, which is exactly the angle of the circle. So it is a very easy equation to remember. The angle is given by the ratio of arc length divided by the radius. It is the same technique that is used in the parallax method. Parallax method is used to measure very large distances. So the radius in this case is almost tending towards infinity. So if we observe, as the size of the circle increases, its curvature becomes lesser and lesser. So as the radius goes towards an infinity, the arc almost looks like a straight line. So from the earlier equations, if we look at the figure 2.2, the angle theta is given by the ratio of arc length, which is small b here, upon the radius, which is d. So theta equal to b by d. If we rearrange the equation, we will get d is equal to b by theta, and hence we can find the distance of the object d. So that is the most of the important concepts from this chapter. If you wish that I have to discuss some of these problems, you can definitely tell that in the comments, or if you want any other suggestions, you are always free to do so. So until next time, see you. And I am wishing to do a series like this to cover all of the chapters. And if you have any suggestions, yeah, do tell me. Yeah, bye.